This is my VR photo viewing app I created. This builds on my learnings and experience gained from my VR roller coaster project. After building 2 projects in Unity, I chose to use Unreal Engine for building this. And I decided to build this for 2 reasons. The first being I needed a way to view my own 360 photos. And second, because at the time I couldn't find a simple app out there to just view my photos. Most of the apps were for 360 video viewing as their primary function, and maybe you would be able to view your images. I built this with simple navigation and a clean and easy to use interface. Some of the features include viewing a gallery of thumbnail images and navigating your picture file directory. Also includes viewing regular and 360 images, including rotating, scaling, and panning of images. There is also a slideshow feature, and the app is built for efficiency. It uses worker threads to create thumbnail images that are stored in a SQLite database. The goal for all of these features is to make the interface as responsive as possible. I'm going to walk through some of this. This is the main scene. So what happens when the app is launched? The main scene will load the startup screen. The startup screen is responsible for doing some of the work in the background before the app is ready. The first thing that happens is the splash screen is presented, so the user has something pleasant to look at while the rest of this heavy work is being done. Next, we prepare the database. If the database doesn't exist, it will be created, and then an integrity check is done on the database. If that fails, then the database is deleted and recreated. And next, the gallery is spawned. So this is the BP gallery. The gallery is responsible for displaying all of the thumbnail images. So once that is spawned, then we can create our object pools. So there's this BP image preview that is used in this object pool. So I believe we create 100 of these. So they are ready as soon as the app is ready. Now, once the startup screen is finished, it will load the environment. The environment level will display the background environment, which would be a cube map. Now, once the environment is loaded, it will load the navigation. The navigation level is solely responsible for allowing input from the controllers. So the targeting and the horizontal move of the gallery are now enabled. Now, once that is finished, the audio is loaded, and then the app is ready. The splash screen is removed. Now we're in the BP VR pawn, which is the player pawn, which is also called an actor. There isn't much to see in the viewport. There's the camera and the controllers just sitting there, waiting for it to run. And you can see here in the scene we have the right controller and the left controller, and I have some attachment points on here for the pointers. And then I will also use these for the labels. You will see that in the video of the labels that are attached to the controllers, and these are these labels. Then over here in the graph, these are the nodes in the blueprint. So I arrange these by colors. It helps me navigate quickly. So this is the begin play. It initializes, does some initializations, and then it also has all of my listeners. Then down here are some controller inputs. So we have the widget touching component for the widgets that are displayed. This one is the rumble for the playing the haptic feedback. And this is the widget touching component as an example. And then there's some code for pressing the A and X button that's for selecting a thumbnail image. Over here we have all of the inputs for the controllers. So we have the rotate up here. Here's a rotate of 360 for yaw, pitch, and roll. And I'm checking to see what mode it's in. It's a sphere or it's not a sphere. And then when it's a smooth pitch, roll, or yaw, then it calculates the access value. This is the code for the slideshow. And that you'll see in the controller, it'll say next or previous. And it will also have a timer in the widget that you can set at how fast you want the slideshow to go. This is a BP gallery, and it doesn't have anything in its viewport either. This is the graph. So the responsibility of this blueprint gallery is to display the thumbnails, all of the thumbnails in the scene at their correct position. And it also will communicate with each one of these images. And it also has event listeners on them. Then we have the BP image preview, which is the individual thumbnail image. There are 3 meshes on here. Depending on which image we have, it'll either be a sphere mesh, a quad mesh, or a folder mesh. And it has quite a few attributes on it, just a ton of attributes. We'll go over to, these are all of the blueprint functions here. This is an example of one of the widgets. And over here is the graph. So back here we have our picture folder location. This is where we start when we put on the headset and start the app. And the user can change that. The music level, the sound effects level, the slideshow speed can go from 0 to 10. You can turn off your tooltips, turn off your haptic feedback, and clear your cache, or decide not to use cache. All right, up here we have our references initialized and all of our listeners. Also the save game. These are settings that perpetuate between sessions. So the save game will be pulled and populate the fields in the settings. So for example, the user changes the audio level and then quits the game. The next time they come back to the game, the music will be at that new level. And that is all I have to show you for the editor today. Okay, let's look at some code. This is the gallery C++ file, and it is the file for the BP gallery blueprint that I showed you in the editor, which displays the thumbnail images and their locations in the scene. And it uses a texture process helper over here that I created to manage a thread that will process the image for displaying. So it has the, it basically will manage this thread by shutting it down if there's no work to do, and then waking it up when there is something in the queue. Right there. And the thread, all it does is grab something from the queue, and it calls this load image from disk. So basically what this does is it first will check the database. I'm using a SQLite database over here. You can see it in the solution on the right. It'll look in the database, and if it's not in there, then it will grab the image, the metadata, and it will create the thumbnail and store it in the database, and then it will create a image data object and put all of the attributes, assign all of the attributes to it for the thumbnail, and then, if I didn't mention compression, compresses before it goes into the database. And then, oh, I do the bitmaps too. So I run it through this code here to create the 10 bitmaps. And there's the creation of the texture, assigning the size. Yeah. And then when that is all finished, it is broadcast back to the blueprint. So if I go, there it is, broadcast back on the game thread, because we're not using the texture processing thread is not the game thread. So we have to pass it back to the game thread, and it broadcasts it back to the blueprint with the location, and then the blueprint will, the gallery, BP gallery, will display it. So that's how that works. And let's see if there's anything else that's interesting. I use a lot of asynchronous code in here. So in the gallery, to get all of that directory of files, I use an asynchronous call from there to get those and put them into the queue. And let's see if there's anything else interesting in here. That's probably like the most interesting code that I've written for this. And yeah, I have a SQL file in here that I created for creating the database. That might be it. And checking the integrity and all of that. Pretty standard SQL, parameterized SQL for that. Oh, just, you know, that's about it. That's what I wanted to go through today.